Hello, my name is Sweenus, and in this tutorial I'm going to show you how you can set up shader permutations. We'll be working with the custom shaders tutorial code so you can see exactly how it works with an existing example. Link to the GitHub repo is in the description. But first things first, what are shader permutations? They are effectively hard-coded variations of shaders where one shader gets compiled out to many variations of that shader. This is also done when you use a static switch parameter in your material or change some sort of material property. We do this by setting the environment variables, kind of like how we did in the custom shaders tutorial, however, using the permutation domain object instead. Otherwise, we would have to create a new global shader for each variation. This means that the engine will call the right permutation depending on the values we give for each permutation vector, as it creates a shader for each and every permutation that gets used. It's worth noting that there is a limit coded into the engine. It's 832 permutations, but if you have substrate enabled, it goes up to 1,368 permutations. To get started, I'm just going to explain what I've added to the shader, as technically we don't actually need to make any changes, but I did in this case anyways. So at the top, I've included a bunch of definitions. Specifically, if a macro isn't defined, define it here with a default value. And I've also provided an example of an error if the macro has a wrong value. And that's literally the only changes I've made. Everything else remains the same. Now moving on to the global shader class, we add in these classes that extend the permutation macros. These macros fill in the class code for us. You can see the actual class is used by the macros in the shader permutations header. There are several types to choose from. We have the bool permutation, which is pretty straightforward. It's either true or false or 0 or 1. We have the int permutations, which here it's set to 5, which represents the values from 0 to 4 inclusive. And then we have int range, which here represents the value from 2 to 4. We have sparse int, which can provide specific values. Here you can see some of the powers of 2, but these could be any number of values and any amounts. And then the number of permutations represented would be how many actual numbers you put in here. And then we have the enum permutations. These would require that your enum be contiguous in terms of the first value is 0, the next enum value is 1, etc., etc. Next, we set up the permutation domain, passing in the classes as the template types, and then modifying the compilation environment. We have this cool little optional thing we can do. We don't have to do this, but I'm just going to show you that you can do this anyways, where we take one of the permutation values and use it to set another macro in the shader. In this case, it's the one that we actually use for the shader itself based on the bool permutation. So the first thing we do is we get the current permutation, and then from that we get the permutation value for one of our permutations, and then from there we set the macro in the shader. In the implementation, everything's pretty much the same except for these lines. Here we create our permutation domain and then set our permutation values. And these values need to be within the bounds specified in the global shader. Then we include our permutation vector here. Before it was just a global shader map, but now we pass both. And that's pretty much it. Everything else remains the same. And now you can set the macro definitions in shaders all easy like. If you found this tutorial helpful, be sure to give it a like and let me know in the comments. As always, thank you for watching.